Now we're going to do a problem where we go one step beyond the empirical formula. Remember, to determine the empirical formula, we go grams of each element, moles of each element, mole ratio. Grams of each, moles of each, mole ratio. So once we have the mass of each element, we divide by the atomic weight. We can get to the moles of each element. Then we're going to find our lowest whole number ratio, which is our empirical formula. Then once we have the empirical formula, we use an extra bit of data, our formula weight, in order to determine the molecular formula. In this problem, we've already determined the empirical formula. We just want to get to the molecular formula, the actual number of each type of atom that's found in one molecule of this compound. To do it, we need one additional piece of information beyond the empirical formula, and that is what the formula weight of that element is. From the empirical formula, I'm going to calculate what the empirical weight is, or what is the mass of one empirical unit. So we have carbon plus 2 hydrogens plus 1 oxygen. So this empirical mass, empirical weight, is going to be 30.03 grams per unit. So we want to see how many units there are in a molecule. So if we have 90.08 grams per mole, and we know that there are 30.03 grams per unit, in this case it tells us that there's 3 empirical units in each molecule. So we can take our empirical formula, multiply each of these subscripts by 3, because there's 3 units, and each unit has 1 carbon, 2 hydrogens, 1 oxygen. And we do this multiplication to get C3H6O3 as our chemical formula, or our molecular formula. Same thing. Okay, now remember the difference. A molecular formula refers to only covalent compounds, and it tells you the number and type of atoms in one molecule. And the empirical formula is the lowest whole number ratio of atoms.